Hello all. I implemented the complete coverage algorithm using bound and rectangle method. These are the CDP versus time graphs. You can see that the paths are greedy. Initially the slope is very high. Coming to their efficiencies, although the graphs for both heat maps are very similar, their efficiencies are pretty different. For heat map 1, the efficiency was initially very low. To understand what happened, I plotted the graphs only up till t equal to 1000. Uh, then I observed that up till t equal to 200, uh, the path 1 increased, the CDP in path 1 increased slowly compared to path 2. This may be because it encountered only low probability nodes initially after entering the bounding rectangle. But at t equal to 900, the CDP is almost the same in both graphs. When I look at the efficiency though, it's still less than heat map 2. To understand this, I plotted the B values and observed that the B values for heat map 1 are consistently higher than that of heat map 2 at all times, even at t equal to 900. This may be because heat map 1 has more of the highest probability nodes compared to heat map 2. So these two reasons, like low CDP initially and high B value, led to the poor performance of heat map 1. Coming to the algorithm, it can be considered as an AI search problem because it has all the attributes: initial state, goal state, actions, success functions, and also the path cost. It is basically an uninformed search, but it's also partly greedy because it's going for the rectangle which has highest probability nodes first. And this algorithm is very similar to the one talked about in the paper, but there is only one modification. I changed the rectangle to hold all the highest probability nodes instead of the non-zero probability nodes. This makes the UAV path more greedy. To reduce the turns, I divided the rest of the area into four non-overlapping rectangles. uh, However, it's not completely efficient because I do not know which is the closest rectangle to the position I'm currently in. For example, I know I land on the right side of the bounding rectangle because I'm starting on the left side, but I do not know whether I end on the right top or the right bottom. So I cannot decide. I cannot always go to the closest rectangle. So that makes it less efficient. Theoretically speaking, if we know all these, if we have all the information, it would take the same time as the simple non-greedy lawnmower path. This is one way to reduce the number of turns.